DMA50 has been specializing in vibration engineering, reduction of noise and vibration since 1968. DMA50 has combined its expertise in vibration mechanics with its need to characterize the physical properties of materials to develop innovating instruments for mechanical characterization. DMA50 is a compact desktop DMA offering a unique combination of high excitation force and outstanding flexibility, which give it capabilities to perform numerous materials mechanical analysis from simple glass transition determination to immerse test, and makes it a real thermomechanical testing platform. Dynamic mechanical analysis may be performed either at room temperature or at controlled temperature from -150°C up to 600°C. The material's excitation may be applied at frequencies from 10-5 Hz up to 200 Hz. The force may be controlled up to plus or minus 50 newtons, making possible to accommodate with specimen dimensions representative of material structure. Amplitude of deformation may be applied up to plus or minus 3000 micrometers. The DMA50's mechanical test frame has been designed to be easy to use and to offer a premium ergonomy. In the upper part, the thermal chamber includes a window to visualize the specimen while testing. Because of the large space available in the test station, the access to specimen and specimen holder settings are very comfortable. The bottom part includes the 50 newtons electrodynamic shaker, the force drive, the displacement measurement channel, and all measuring electronics. All commands are driven by software. The sole manual drive are corresponding to the position settings to accommodate with the specimen dimension and position adjustment. DMA50 allows to measure all viscoelastics magnitudes such as Young's modulus, E, E', E double prime, the shear modulus, G, G prime, G double prime, dynamic viscosity, eta, eta prime, eta double prime, delta, tangent delta. It allows to perform to determine materials characteristic points such as TG, melting point, gel point, and to run a large number of mechanical tests in characterizing frequency dependence, master curve strain dependence, creep, stress relaxation, curing follow-up, aging, and even the influence of the immersion inside a liquid. Most of materials may be analyzed with DMA50. Thermoplastic polymers, thermosetting polymers, composites, adhesives, paints, varnishes, plasters, cements, foods, cosmetics, pharmaceuticals, oils, biomaterials, glass, ceramics, metal and alloys. According to the purpose of the experiment, the tests may be easily defined from a model menu of Dynatest software. Dynatest is suitable as well for experts and beginners. Dynatest offers all possibilities to define any new experiment by a minimum of actions, or at the contrary, to set all parameters, enabling to run specific conditions of test. Advanced algorithms are used to control the exact conditions wished for the test. Dynatest makes possible all parameters combinations to offer practical and efficient solutions to searcher and laboratory. Temperature ramp tests may be performed for one single analysis frequency, or with scanning several frequencies. Such test is certainly the test used the most currently, as it allows to determine the material's glass transition with a high accuracy. Frequency sweep test may be defined without quite any limitations of number of points, either value selection at room temperature or over a selection of numerous temperature-controlled stages. DMA50 makes possible to determine the material's master curves from a test performed over a large domain of frequency and temperature. The master curves computed for one reference temperature allows to extrapolate the material's characteristic far beyond the frequency domain of the test. The non-linear behavior of materials such as elastomers may be easily characterized by sweeping the amplitude of excitation at a fixed analysis frequency. A thermal transformation process can be simulated in a DMA50 experiment. The constant monitoring of the shear modulus at constant temperature or over a specific thermal cycle and the efficient auto-control accommodating with huge materials modulus variations during the chemical reaction allow the determination of the process characteristic time. Minimum viscosity, gel time, reaction time, such capabilities offers huge analysis capabilities for the thermosetting polymer polymerization, cements and plasters drying, curing of foods. Creep tests may be performed by applying a static force and measuring the resulting displacement of the material specimen. Such tests may be applied as well automatically over several consecutive temperature stages. From a single short creep test performed on several temperature stages, Dynatests can calculate a creep master curve allowing to predict the long-term creep behavior of the material over months or years. Similarly to classical universal tensile machine test, DMA50 may perform as well tension and compression test by increasing the static tension or compression force applied to the specimen at constant rate. According to the huge variety of materials that can be analyzed by DMA50, O1DB Metrovib has developed a large range of specimen holders offering important technical and practical benefits to address as well as dynamic test as numerous static thermomechanical tests.